Good morning. This is Richard Yang from Altair Engineering. Welcome to the Altair Enlighten Award webinar on this Earth Day. Altair Enlighten Award is the only award dedicated to lightweighting and sustainability in automotive industries. So this year, we are actually entering the 9th year of the award. Together with Carl, we are continuously making the award more recognizable globally. So here in this slides, I would like to draw your attention to the end of the entries will be the end of the May. And the award will be delivered on the August 4th and 5th. For this year, we continue to discuss how the award is going to make a bigger impact and higher level of the values to the societies. So together with Carl, we are introduced 2 new categories related to sustainability. One is sustainable products, and the other one is sustainable process. So essentially, we try to discuss about the recycling, discuss about the fuel emissions, and how we are going to reduce those to minimize the impact to the world. So as this is an emerging technologies, Carla Bailo, I believe everybody knows her well as a CAR's president and CEOs. We'll have a panel discussion this morning with the industry experts to share us their views on sustainability and the judge criteria for the best effort. Please, Carla, please continue.
Yes, thank you, Richard. And I'm really excited to have this panel discussion today with 2 ladies that are really experts in the field of sustainability. And, for the automotive industry, Earth Day is almost every day now, with all the announcements in electrification, all the work that's been done in manufacturing plants. There's a lot more we can do. There's a lot more innovations that need to be put in place. And we're here to really talk about those and how the polymer world and how Ford Motor Company is really stepping up to the plate for some of the sustainability initiatives that are needed throughout the industry. So we're going to have a presentation from both Gina and Debbie today, and then we'll move into a panel discussion. As the slide showed earlier, which you may have missed since it was before 10:30, if you have questions, please submit them in the Q&A portion. It's down at the bottom of the screen. And without any further ado, I'm going to hand the podium over to Gina Oliver from the American Chemistry Council to share what's happening with their members in the realm of sustainability.
Great. Thank you, Carla. And good morning, everyone. Everyone can hear me okay? I'll take that as a yes. Thanks, Carla, for the introduction. I'm happy to be here today on Earth Day to discuss what better time to discuss the important sustainability commitments that the American Chemistry Council automotive team is undertaking to help create a more sustainable future for our industry and for the planet. In fact, we're continually developing new automotive material technologies and innovations to reduce greenhouse gas emissions now and in the future. By way of introduction, the American Chemistry Council automotive team is 18 member companies strong, all working together with automakers and the value chain to create and deliver lightweight, sustainable polymer innovations. Next slide, please. Nearly every quality of today's modern vehicles rely on plastic and polymer composites, from safety and performance to efficiency and aesthetics. In fact, today's cars, the volume is 50% or more of plastics, but less than 10% of each vehicle's weight. And we're working together closely with the automakers and the value chain to provide the necessary solutions for a rapidly changing automotive landscape, as Carla alluded to. And to that end, the team recently released its Automotive Plastics and Polymer Composites Roadmap for Future Mobility, the cover page you can see on the screen right now. And we're working through this roadmap with the value chain, all providing input so that we can make sure that we're addressing those current automotive megatrends and ensuring that we're providing as the plastic and polymer composites industry the solutions that automakers need to make this future mobility a reality. Next slide, please. The roadmap captures plastic and polymer solutions and innovations within an access framework, which, as you can see here, is autonomy, connectivity, circularity, electrification, shared mobility, and sustainability. And on this slide, we can see several examples. These are just cutouts from the roadmap of the ways that sustainable lightweight polymers are already helping the automotive industry capture opportunities within this access framework. And I encourage you to go out to our website, automotiveplastics.com, where you can see the full roadmap. Next slide, please. So if we're really, driving into that access framework and narrowing in on the C for circularity and the S for sustainability for today's Earth Day discussion, it's very important to the automotive team and each of its member companies. There are deep commitments to creating plastic and polymer solutions that promote a more sustainable supply chain and vehicle designs, which is why we felt as a team that it was really important to facilitate and publish this roadmap or report called the Transitioning Toward a Circular Economy for Automotive Plastics and Polymer Composites. And we're identifying in this report how the value chain can work together to achieve a more sustainable and circular future. Next slide, please. So if we dive in a little bit more on this report, we're talking about, especially when it comes to sustainability, a circular economy and moving more toward a circular economy. So aspirationally, a circular economy is one in which, by design, no molecule is wasted while continuing to meet performance requirements and bring value throughout the supply chain. So while a linear economy, a traditional linear economy, follows a make, use, dispose path, a circular economy is designed to keep those resources in use for as long as practicable. By extracting the maximum value from the materials while in use and recovering and reusing the materials at the end of life. This is the type of comprehensive thinking that has significant environmental benefits, supports longer product lifetimes, and presents the U.S. and the automotive industry, which I'll talk about in a moment, with a significant business opportunity. Next slide, please. In fact, a recent study shown here by Accenture found that the value of the circular economy in the United States is expected to hit $4.5 trillion by 2030, 400 to 600 billion of which could go to automotive companies and their suppliers. So a big opportunity there. Next slide, please. A transition toward a more circular economy, which you see here, will require us, along with the entire automotive chain, the value chain, to rethink the ways vehicles and their materials are designed, constructed, used, and handled at end of life. Next slide, please. And many automakers are already making important advances, which is very exciting, by implementing initiatives to improve circularity and sustainability in their operations. And some are already specifically related to materials and plastics. You can see those examples here, but I also want to point out that numerous automakers have also begun establishing vehicle recovery networks, which is so important for circularity, that set up closed recycling operations, closed loop recycling operations for the recovery of automotive parts and components once they reach end of life. Next slide, please. As you can see on this slide, the automotive plastics and polymer composites industry and our members are working to help automakers meet these goals already by increasing the use of recycled materials in their vehicles. By repurposing plastic waste and recyclables into automotive materials and parts is one way that we can really move more toward a circular economy. And I'm not going to read each of these in the interest of time, but please know that Carl will be making these slides available to everyone. Next slide, please. In addition to materials made from recycled content, the industry is also working to develop plastic and polymer composites that use renewable materials. In addition, the addition of raw materials, such as plant-based oils and naturally occurring fibers are diversifying our industry's feedstock options, all while helping automakers meet their emissions reduction, sustainability, and circularity goals. Next slide, please. Proper washing and sorting for recycled plastics into single polymer groups can be very challenging. And we're helping by contributing new technologies in several areas you can see on the slide, such as better solutions for cleaning plastics before recycling. And we also have the unique ability to incorporate tracing additives into our materials that will help facilitate automated infrared sorting. Next slide, please. Plastics producers are working with partners in the value chain to rethink the design of components with end of life in mind. Several examples are seen here from Solvay, Dow, and ExxonMobil, just to name a few, and also the U.S. Department of Energy's Remade Institute. Next slide, please. Another essential tool for a circular future is the development of advanced recycling, which converts plastic waste into feedstock that can be used to create a variety of products, including new automotive, polymer, and plastic products. At least 60 organizations, including many ACC members, are working to scale up these emerging processing methods. Next slide, please. By their nature, plastic and polymer composites offer OEMs and part suppliers tremendous flexibility to increase the efficiency of their manufacturing processes, which is a key aspect of circularity and also promotes a more sustainable future. With plastics, manufacturers have a wide range of available options for reducing waste and improving efficiency through approaches such as parts integration and the use of regrind and repurposing of defective parts, which are just a few examples. Next slide, please. So during the roadmap, we learned a very important thing, which is that effectively removing plastic and polymer composites at the end of life from vehicles and then having the ability to recycle and reuse them is not going to just require improved technology for those processes, but also very close coordination by the entire automotive chain with the recycling value chain. It's very important to do that together in order to be successful. And we've already taken steps in the right direction, including undertaking projects that explore collecting materials and recycling them at the end of vehicle life. In fact, we're right now today have developed and implemented closed loop recycling processes, including recycling more than 95% of battery cases that are then used to create new cases. Next slide, please. So clearly the automotive plastics industry and the automotive industry at large are working hard to transition toward a more circular economy and a more sustainable future for the planet. But still there's so much more work to be done. And the automotive industry and its material suppliers will continue to need more solutions to achieve full circularity and become truly sustainable, which is why we've taken steps along with the value chain to help fund R&D in a variety of areas. For example, the Alliance to End Plastic Waste and its members and supporters have committed to invest $1.5 billion towards solutions that will help recover and create value from plastic waste. And the Institute for Advanced Composite Manufacturing Innovation, or IACME, is also funding several projects on circularity and recyclability for fiber reinforced plastic composites. And finally, the U.S. Department of Energy is making significant investments as well, including providing approximately $43 million through their Remade Institute in research and development that will enable U.S. manufacturers to increase the recovery, recycling, reuse, and remanufacturing of plastics and other materials. Next slide, please. So in conclusion, final slide here, where the automotive industry is definitely moving toward a more sustainable future and a circular economy. And this will take time, but it's a worthwhile journey, and it will have tremendous environmental and potentially economic benefits for the industry, which I discussed. You can view, again, the full roadmaps, both of them, at automotiveplastics.com. Feel free to contact me if you would like to learn more, or maybe how you can get involved. And also wanted to flag that we are continually providing updates and information on progress on almost a daily basis on Twitter. So please follow me at G. Marie Oliver to keep up with the latest developments. Thank you very much, and I will turn it back over to Carla.
Thank you, Gina. That was a great introduction to what's happening in the polymeric world. I just have one quick question before I have the next presentation. You showed some of the funding sources that are available. Are you seeing more and more funding become available under the new administration with the clean energy goals that are being established?
Yes, absolutely. Even recently, as recently as last week, the Department of Energy put out a very large funding opportunity, and I believe about 37 million of which was tagged specifically for sustainable automotive solutions, particularly in the EV space and EV charging infrastructure. So they're aware, and I might be able to talk about it a little bit more in the Q&A with some additional details. But they're supportive, and they're aware that they're going to need to provide significant funding to make the sea change that we're really seeing the Biden administration signaling needs to happen.
Great. Thank you, Gina. I'll turn the floor over to Debbie and Dr. Debbie Milowski from Ford, one of the renowned resources in some of the work that she's done, everything from coffee grounds to dandelion leaves and more. So I'm really excited to hear your presentation.
So good morning, everybody, and happy Earth Day to everyone. Thank you, Carla and Richard, for inviting me to speak today. And thanks, Gina, for a great presentation. Can't wait for the chat after my little peek behind the curtain at Ford Motor Company. My name's Debbie Mielewski. I'm the newly minted Technical Fellow of Sustainability at Ford. That's the first time we have a Sustainability Fellow within Ford. And so that sustainability is taking a front row seat at our company. I've been at this for 20 years, and I just want to show you some of the stuff we've done in case you're unaware, and then a little peek behind the curtain at what's to come in automotive and sustainable materials. So next slide, please. So just for fun, I am not the inventor of sustainable materials at Ford even. Henry Ford did a lot of work in this arena in the 1940s. The upper left picture is a picture of a soybean squeezing facility, extraction facility. And Henry Ford was using soybean oil in enamel paints way back in the 40s. He was so fascinated with the soybean, he even made the suit for himself on the lower right-hand corner. The only issue with that suit, it was beautiful, is he didn't know how to wash it, so he didn't. Henry Ford is shown by a car that incorporated many sustainable agricultural products in it, up in the upper right. And in the lower left, he is hitting a soybean containing plastic fender with a sledgehammer, demonstrating how it rebounds versus a steel one that would dent. And so Henry Ford thought that working with farmers was critical that he should use their products and they in turn would buy his products. And he was obsessed with using byproducts of agriculture, which I think is a fantastic idea. And I've dedicated the last 20 years to it. So next slide, please. Why in the heck are we looking at biomaterials? My list gets longer and longer every year that I put into working on it. We're using agricultural feedstocks, side products of agriculture. I'll show you some of those. We're producing revenue that farmers never dreamed they'd be able to get. Wheat straw was burned in the fields for some of our Canadian farmers. It's much too cold to put a large portion of it back into the soil. And so they would light it on fire, producing CO2 with no human benefit. So we are taking that wheat straw, putting it into storage bins, and it does a great job in that application. We can use recycled and waste products. I'll show you some of those. Reduce dependence on petroleum, better life cycle for our planet. Some of the materials, nature is very, very adept at optimizing, and the materials that we're using and inventing have better energy absorption. We see they have better high temperature properties. And so just because it's coming from the earth, just because it's renewable, doesn't mean it's doesn't meet specifications. As a matter of fact, they all exceed our specifications. We increase our material choices. Our customers are aware that we're using things that are better for the planet and they're lightweight. And so it improves fuel economy. So I just keep thinking, with a list this long, why the heck aren't you doing more of this? Next slide, please. And so this is a little peek inside of our laboratory. It's somewhere between a farm and maybe a landfill facility. You can see we're working on the upper right, natural fibers of all different types, tree fibers, wheat straw, coconut fibers. We are working on many recycled materials because there's a wealth of materials that people consider to be garbage that we think is gold. Things like shredded money, when it comes back from circulation, that fiber has excellent, excellent properties and can be used to reinforce plastics. Of course, bottles, we've done a lot of work. Under body shields was the most recent one, millions and millions of pounds of bottles being recycled by Ford. And we've used the shoddy as an insulating, sound insulating material from jean cuttings, from towel cuttings for many, many years in our industry. Bio-based resins from dandelion roots, sugar cane from Brazil can be made into plastic, corn can be made into plastic. We can ferment and make brand new polymers. And then finally foams, which was our first application within Ford, soy-based foams. We have castor-based foams also in production, and we're looking at other oils. Any oil that's in excess can be modified and used in a polyurethane foam. Next slide, please. So lots and lots going on in our lab. This was our virgin voyage into foam in 2000. And I just wanted to show you this because it's such a simple idea. Basically, we're taking soybean oil and replacing petroleum oil that is in the current formulation with a soybean oil. So we hydroxylate it the same way they do the petroleum oil that comes from the ground. We add it into a polyurethane formulation in part. It's a secondary polyol, so we couldn't replace all of it because the cycle time would be too long. But anyway, simple idea to replace petroleum oil with soybean oil and make yourself a polyurethane foam. And that's what we were doing around 2000. Next slide, please. And we got some miserable foam. So don't expect anything to be easy. And I think this is a major source of failure within the world, is that people make that substitution. They see that ugly, stinky yellow foam and they say, can't be done. And we were told it couldn't be done many, many, many times, even within Ford Motor Company itself. And so you need to be persistent. We have a slightly different oil material. It's a secondary instead of a primary oil. All of the chemistry needs to be rebalanced. It's not impossible to do. And the carrot at the end is so big. The world has soy-based foams that meet automotive specifications. It's in every single vehicle that Ford makes today. So next slide, please. So we go from that stinky yellow foam to, I call it Geek nirvana, because here we are in late 2007, and Ford implements soy-based foam on the Ford Mustang. Shock of my life that it actually went in. And it turns out it went in for very good financial reasons. Oil spiked at $160 a barrel at that point. When we started working, it was $20 a barrel. And so that's why people were laughing, like, what the heck are you doing? But here's the end result. There's Times Square, New York, and there's our little soy-based foam seat going into production. And then it made its way, it migrated to every single North American built vehicle for seat cushions, backs, and headrests. Next slide. I could talk all day, but I'll have to keep moving. We were so geeked up about that soy foam implementation that we started working on wheat straw, which takes, after the food portions removed, we dry that wheat straw, grind it, and incorporate it into polypropylene for bins in the Ford Flex. Not a glamorous part, but you can see that it's lighter in weight, that it reduces the amount of petroleum you use, and you still get some CO2 emissions reduction. So why not do it? Next slide, please. So that was 9 farmers in Ontario, Canada, that were working with us on producing the wheat straw. Canal fiber, this was done with IAC in 2013. It was replacing ABS with a lightweight door bolster. So there's 4 of those on a vehicle, significant weight save, so improves the fuel economy, better for the planet, and just all around a better solution. Next slide, please. And so now what are we up to? We have spent the past few years focusing on trees, because trees are it's one of the most abundant sources of material on the planet. We are using the waste from the lumber industry. And you can see our first implementation was an armrest substrate, which replaced glass fiber entirely with tree fiber. That was on the 2014 MKX. For the console substrate on the Continental in 2018, it was a hybrid. We used a little bit of glass to hold the dimension of the tool, but a good majority of that was cellulose fiber, and we saved over 1.5 pounds of weight on that one. And then most recently, we're proud to say we put tree fiber into sill shields on the F-150 and 250. This is high volume, and so we finally made it into big time with weight reduction and tree fiber materials. Next slide, please. And in December of 2019, we were super excited. We had been working with McDonald's for a few years on using their coffee chaff. And chaff is the skin that comes off the bean during the roasting process. McDonald's sells over 1 billion cups of coffee per year. So the chaff is pretty deep at their plantations. And again, no application to use that for. Sometimes they burn it. And so we put it into headlamp housings. We replaced 40% talc. That's a heavy part, with less than 20% coffee chaff. Exceeded all of the mechanical properties, lighter weight, saved 0.5 pound per headlamp housing. And look how much fun I'm having driving that car with McDonald's coffee in the bottom. So we're having a great time while we're trying to help the planet. Next slide, please. And this is one that I didn't even realize we grew rice in the US, but we do in the southeast portion of the country. This is 6 parts that we put on some of our high volume vehicles. Again, wiring tracks. Everybody said that you cannot use rice hulls because they absorb too much water. They absorb more water than talc. If you look at the data there, it's true. The rice hulls do absorb more, but it's 0.4% by weight. And so the caveat here is that is not a lot of water. And so we were able to put these in, meet all of our specifications, have no issues, produce revenue for the farmers, again, in this instance, that they never dreamed of having. Next slide, please. And I love coffee, but I also love a good margarita. And so, I just want to give you a peek behind the screen, how much fun we have. I said, geez, I'm going home, have a margarita. We should call Jose Cuervo on Monday and see what kind of waste products they have. And so it turns out that piña that is rolling off of the truck is about 70 to 100 pounds. It takes 6 years to grow. When they squeeze the agave from the piña, the fiber is a leftover product, and it causes all kinds of environmental issues in Mexico. Rats enjoy the sugar that is left in that material. And so they are looking for uses for it. And the parts on the right are window mechanisms that are being tested. So far, so good. You may see Jose Cuervo's fiber, agave fiber in our parts. Lighter weight, better for the planet, and an industry first, let's hope. Next slide, please. And this is one that keeps me up at night. Everybody hears about ocean plastic. We've been working with DSM on the turtle in the center. So you got to start someplace, and we know the fishing nets are being discarded. They are an incredibly premium nylon material. We've tested them, and the material is prime. It can be substituted in for other nylon parts in automotive just fine. And so we're working hard toward implementing there. Next slide, please. And then the future is coming. Can we, this is my dream, can we sequester our own carbon dioxide emissions? We want to reduce them as much as possible, but can we sequester them and make things out of them? And we've already demonstrated that you can make foams, pretty good foams that meet specifications out of carbon dioxide. We're also making carpet, we're making fabric. And so that's my dream, is to turn CO2 into plastic materials for brand new vehicles. Next slide, please. And another sort of dream is, everybody criticized us for saying, we were going to replace 100% of glass or carbon fiber with natural fibers. They said, no, natural fibers just aren't stiff enough. Inherently, they're never going to meet. And so what we're trying to do here is produce fibers that are stiffened through having the plant absorb nanoparticles either through soil or through water. This is our Nobel Prize effort here. And so far we have been able to get certain plants to, it's a long-term project, to take nanoparticles in, and we're in the process of assessing whether we've stiffened them or not. So the future is bright. We need to do these things, and we need to try really hard. So don't expect that when you try something, it's just going to work. We tend to invest years to get these things into our products. So thank you.
Thank you, Debbie. That was fabulous. I could have listened to you a lot longer. And I guess, the one thing that resonated with me so much was when you kept saying everybody said it couldn't be done. So, that you just keep trying it, and you keep finding the solutions. And, there are so many, especially engineers like me and, you yourself, that people say it can't be done, or we have a specification that, you have to stick to that cookbook. And we really need to break through that to allow some of this, ingenuity to make it real.
Yes.
I just had one quick question, and you can address my thought too when you answer this question. But you were showing, in the lumber, in the processes that you're using some of the scrap materials and the agave, et cetera. Does it require any additional work at those sites or change in processes, or is it as simple as what they normally take to burn or take to some landfill or just throw wherever, that it just comes to your house, so to speak?
That's a great question. I'm glad to have the opportunity to clarify it. Yes, it takes building a supply chain, building an industry, because the sugar has to be washed from that agave fiber, for instance, in the Jose Cuervo case. So we have to work with them or work with other suppliers so that either they clean it or it gets shipped to another industry which cleans and chops it. Chopping natural fibers is not like breaking glass or breaking carbon fiber. So a whole new supply chain generally has to be developed. So we are always looking for partners that have an interest in doing something new and different, because that's what it's going to require.
Yeah, and then to go back to what I was talking about initially, what gives you that fortitude to keep going over all these years? I mean, you've seen ups and downs in terms of people being happy with, recycling or having it on the agenda or not on the agenda, and now it's hot again. I hope it stays hot, but what's given you that fortitude, especially if we have some young folks in the audience?
Yeah, so I have the luxury of working in a classical research lab, and generally those projects do take years to bring to fruition. What I keep in mind, because of our periodic successes through time, thank goodness, I know that these things can be done, and the problems need to sort of be addressed one by one. So if the soy smells, the soy oil, you have to remove the odor. Okay, let's work on that. If the formulation needs to be adjusted, we'll work on that separately. And so you should expect multiple hurdles, and that you will address them sort of individually and combine all of that together. I keep going because I know it's the right thing to do. So whether it's popular or not, in the long run, I know we should be using our resources as smart and efficiently as we possibly can on the planet.
Mm-hmm.
Sometimes it doesn't even go into a Ford product. And I always think it doesn't need to go into a Ford product. So if I invent something that's great, but it doesn't meet our specs, maybe another industry like the furniture industry can use it, or the, I don't know, mattress industry. And so we have worked with the mattress industry and John Deere Ag on foams, different specifications, different amounts of soy can be incorporated. So I think of it as, this is one area where we should compete. We should probably all play together toward a better world.
Yeah, indeed. And, one of the questions that came in was, do you ever share this, outside of Ford? Specifically, the question was about other OEMs, but I think, you've addressed that already, that, yeah, you do. You help other industries as well.
As much as possible. And I think the more we can show people that things can be done, the more we can accelerate. So we've worked with Coca-Cola toward, can we take their plant bottle material, which was a blow molding material, and make fabric out of it? And we did that. We showed a vehicle that used plant bottle. We worked with Heinz on, can we take ketchup, the tomato skins and peels and seeds, and put that as a composite into plastic. So the more things we can do and try and move forward on, the better.
Fabulous. Gina, I want to ask you a question. Do you think we'll ever have a 100% sustainable car, meaning it meets the circular economy? And secondarily to that, what do we need to do differently in terms of policy or the way we do packaging, or the symbols that we put on products? I asked that because I lived in Germany for 2 years. I lived in Japan for 5 years, and people often chuckle when I tell them my office in Japan had about 25 different recycling numbers. Yeah. You had to take your own garbage out there. Nobody did it for you. You had to do it regardless of your level, although I suppose the real high up executives, Mr. Goen, didn't have to do that. However, the rest of us had to do our own recycling every day, and it was just the way you did things, and everything was numbered, and the whole country was behind it. So thinking about this 100% circular vehicle, sustainable vehicle, then what about policies, or what do we need to do differently?
Yeah, it's a great question. And, much like Debbie, Dr. Debbie, I like to call her Dr. Debbie. We think that it's going to be a journey, but it's one that we have to take. And we feel very passionate about that. My member companies are extremely committed to a circular economy for the automotive industry and moving toward that. And when you listen to the doctor's comments and her passion and the commitment that Ford has, taken on to create these kinds of solutions, you can see that it is a real possibility. But to your point, we are going to need a lot of support, and there are going to need to be probably policies. And, we already know the automotive companies, as I showed in my slide, are making commitments, public commitments. That's a huge start, because it requires suppliers to rethink the way they're doing things in order to, meet their customers' needs. So, and then, on public policy side, and to your question about, all of the many numbers on your recycling, it's confusing for a lot of folks, and we're working really hard to make sure with policymakers that we can change and improve that. It needs to be a full network of infrastructure, as I said, to really happen. And we're working every day on it. We're talking to policymakers every day on it. And it's beyond automotive, as the doctor said. We're all on this earth together, and we have to create a full circle of solutions, not just within the automotive industry. And I love the example that she gave about creating the supplier network for the wood solution, because that's a perfect example of what I said in my slides. We're going to have to begin creating those unique supply networks in order to reach full circularity. And it's going to be at least in the beginning, on a case-by-case basis.
So Dr. Debbie, I'm going to use that now too, because I love it. Do you have any comments about the 100% sustainable or recyclable circular economy vehicle?
I wake
You have
up
a better
every
chance
morning.
with EVs?
So what we have is we have an industry that has optimized every single plastic part based on the application it's in and the cost, right? And so when you add up what we have, it's 200 different plastic materials. When you say polymer matrix, filler content, etc., right? And so that is a mess. 200 plastics to sort, to reclaim. I would love to see it go down to 10. And honestly, if we had taken sustainability into context years and years ago, it would have been 10. There's no reason it can't be 10. You don't have to design a material for every single application in the interior, exterior, and under hood. You can bind these into categories and use higher volumes of maybe 10 different materials. So I think that's everything Gina said was brilliant. It's going to take a village, but I really think we have to stop this nonsense of every single component is made out of a specific material. And, if we could focus, I love trees fibers because they come in, like 2 millimeter long fibers. They come in microfibers, they come in nanofibers, they come in nanocrystalline forms, and you can get different properties all from tree fiber based on which format you use it in. And so I think that's what we need to move to, is simplifying before we think we're going to get to 100% and just be able to reclaim everything we're using.
Yeah, and that kind of goes back to Gina a little bit. I mean, each manufacturer today has different specifications, even for all those 800 some grades of different materials. Is there an opportunity to do more standardization? Are you seeing those kinds of discussions amongst the industry to simplify and then be able to share and share in the development and, still keep your secret sauce in terms of how you utilize that material? But are you starting to see any conversations in that way?
Yeah, I think we are starting to have the conversations. It's a big mountain to climb because everybody's used to using a foam on a substrate, hard substrate material, cover stock over it. And those three materials are bound together. Switching to a polypropylene foam with a polypropylene substrate and a TPO cover stock so that they're all the same polymer family is really tough in automotive because we're optimized for low cost and high performance.
Okay.
So yeah, I think we got to get there.
Gina, what are your comments on that?
I certainly think with EVs as sort of maybe a test case for the industry, a proof of concept, I think there's a lot of potential there. We talk about that. I talked about the closed loop recycling process for batteries that are in today's vehicles. We know that we can, do something similar for EV batteries. We can benchmark that process. And I think the more that we're able to show the way that things can be simplified and roll those examples out. I mean, it's great that we're doing, this webinar today, but, Dr. Debbie and myself, I mean, we're trying to tell people, listen, there are examples here that you could benchmark and that you can use that will simplify things for you. So we want to get those tools out there. So I think that's part of it, honestly, is just trying to get everyone on the same page and understanding that there's already, no pun intended, some roadmaps available for you that you can use that will help us all get on the same page quicker.
And sustainability needs to take a front seat. Like every decision you make, you have to consider sustainability. Because even within Ford, I know we're not using the same material for battery cases, depending upon program. And how can I take anything back when it's going to be a bunch of mixed materials? And so it has to be first. What are we going to use a thermoplastic case that is easy to recycle? And then just stick with that.
Right. And that's why I think the EV batteries might have some real potential there, because we hear from congressional offices all the time, yeah, we're really excited about this infrastructure, possibility and the Biden administration's plan. But I mean, both sides of the aisle are making it clear we want it to be sustainable, and we want these batteries to be recyclable. Yeah. And so they're very clear about that with the proliferation of EVs, their expectation is that it's sustainable and more circular.
Then I just have another follow-up question. I studied, my minor was in materials, polymeric materials. So we're talking my language here. I love it. But I'll tell you what, I never had a course that focused at all on recyclability or using renewables in any way. Is academia doing a better job in that today to change that mindset of before you design, think about afterlife? Anybody know?
I don't know if Dr. Debbie, I mean, so I think the issues being pushed now, the research universities we work with, obviously are coming to the table because this is a hot topic, right? So they know there's potential there. So I think they're certainly turning their attention to it now, but I'm not aware previously of any efforts or programs in that area, but maybe the doctor.
Yeah, so I think that universities are starting to offer degrees that are either a major or a minor in sustainability. They are getting the coursework there. What I'd like to see is every course in materials science, including it, like you suggested, right? I mean, I think it has to be everywhere, not just my daughter is studying chemical engineering, sustainability engineering, and it can't just be those people because they will be alone in the lab like I've been the past years. It needs to be everybody thinking about it. And here's the big advantage. Like these materials are premium. Carbon fiber and glass fiber break when you mold them. So everybody knows you start with 3 millimeter fiber and you're lucky to have a 0.5 millimeter long fiber left when you're done. Natural fibers bend, they don't break. And so they're infinitely more recyclable and the part is more isotropic. So here's some huge advantages to humans, to automotive engineers that they need to know about. And I don't think anybody knows that but me, right? Oh my gosh, look at this little natural fiber. It's beautiful. It doesn't break.
So let me ask, you mentioned, Debbie, and then I'm going to go to Gina again. You mentioned about we care about cost and performance and mass. And we need to be thinking about this entire life cycle analysis. So how do we measure the economics so that we have the right equation? Because when we're designing a product, we don't look at the full life cycle and include recyclability and include any savings we get from that reuse. Typically, that's not part of how we figure the cost and profit on a vehicle. Are you starting to see changes? And is that, is there an equation that is coming that's helpful?
Maybe I'm just starting to hear engineers at Ford say, you know, especially with regard to battery recycling, is the battery worth anything at end of life? Can we extract materials? What are they worth? Can we put them into new batteries? So thank goodness, you know, as we're launching vehicles, we're already thinking about that in the business case. The thing that I think is really interesting is most of the materials that we have implemented are lower cost. And so these are things that are above ground that farmers are going to take a match and light on fire. They're in a giant pile. Instead of mining, instead of high temperature processes like drawing a glass fiber, the fiber is already there for you. And so I don't see them as inherently more expensive. The problem is the supply chain's not there. And so when I'm going to do it on one vehicle program with 50,000 units, and I'm going to compare the pricing to, you know, something like millions and millions of pounds of commodity glass-filled or talc-filled materials, the business case gets tough. But there's no real reason that wheat straw should be more expensive than either glass fiber or talc that is mined and dragged around the planet and ground up, and all that energy is used. It's ready to go practically. So that's the good part.
Yeah. And Gina, what are some specific examples or initiatives that, you know, the plastics and composites industries are doing that, you know, exemplify this, you know, work for sustainability?
Yeah, so as I talked about in the slides, there's a lot of work underway. So just a few examples from our member companies would be that Solvay has developed UV stabilizers that extend the lifespan of polyolefin plastic parts. Dow has high performance resins and additives that minimize issues like cross-linking and high odor that are commonly associated with some recycled plastics. ExxonMobil has a Vistamax product which compatibilizes PE and PP plastics along allowing them to mix in the melt and removing the need for costly and time-consuming separation of recyclates. And we've got companies like Trinzio and Loop Industries, as well as Indorama, that are working on depolymerization, and others like Eastman, Sabic, Agilix, and BASF are working on feedstock recycling. So a lot of examples there. A couple more that just came to mind. Toyota and Toray are great examples where they've partnered up to build a pilot plant to demonstrate an energy efficient thermal decomposition recycling method for carbon fiber reinforced polymer composites. And that method will thermally decompose the composite matrix resin and use it as an energy resource to recover carbon fiber. So, you know, lots of great examples. I talked about IACME earlier. They're funding several projects that are scalable, and you know, they've got some patents pending for new recycling solutions. But, you know, as Dr. Debbie said, you know, a lot of the problem here is, you know, can it be scaled for high volume? And, you know, because if not, then the cost benefit analysis isn't going to work. But just, you know, to her comments, we're finding that our solutions are in many cases not just meeting current standards, but exceeding them. And so I think that it's encouraging people to be brave, for lack of a better word, and think outside the box. And you know, the opportunities are there. I just think that people, you know, need to just seize the day.
Great advice. And let me ask kind of a fun question. I don't know if it's fun for those who are in the tire business, but we now have the rubber problem with the rubber trees. Is this going to expedite finally finding substitutions for rubber tires that pile up everywhere? What do you think, Dr. Debbie or Gina? I mean, do these kinds of crises help, or?
I mean, I think it helps people panic a little so that they don't rely on the old solution all the time. And so anytime you can get people to say, oh my gosh, there's a market for, or there's a reason, maybe even a national security reason to have rubber sources within our own country, I think it makes sense. So
yeah, I agree. We don't ever want to see, problems, but it certainly prompts the search for solutions. And honestly, that's a lot of the reason why we're the entire planet and the entire automotive value chain is being pushed now, right? To recognize the need to think differently and have solutions. So I think there's a real potential there for tires as well. Absolutely. We can make solutions for almost any problem. That's the beauty of of plastic and polymer composites.
yeah, I always make jokes in my lab. Give me a carbon source and I'll make whatever you want out of it. It may not be the most efficient route, but I can make something out of it. I enjoyed Gina's past answer. I think we're in the mode of being able to think about stabilizing polymers that we haven't stabilized before and think about second and third lifespans. So I love that idea of, yeah, we were only shooting for 10, 15 years out in the field. And now we can shoot for 30 or 50 years with these new stabilizers. And I can bring my natural fibers back and with plastic and understand that they can be processed into the same application.
And I think that bodes well when we talk about a shared economy and maybe the shells and certain components of the vehicle lasting a lot longer and having to be more durable, kind of like the airplane model. But I won't go into that right now. There's one question that came from the audience that I want to ask before I go into the wrap up of the Enlighten Award itself, of which you're both judges. There have been several announcements by European automakers about by when they will be CO2 neutral. Are you expecting same from the US automakers? Will they follow suit very soon? I know the other day Ford said it's not a promise, but this is our intention. What do you think is going to happen? Are we going to match the European? Are we going to forge ahead? Or everyone's going to be on the same page? And any thought at all about that question from the audience?
Well, we committed to 2050 carbon neutrality. I would like to see that happen faster. And so given my new job as technical fellow of sustainability, I've been trying to figure out exactly what are the keys to making that happen earlier than 2050. Mm-hmm. A lot of it depends upon, of course, electricity becoming sustainable source. So hydro or solar. What can Ford do specifically to move our own emissions into neutrality? So I'm going to be looking at the plants and the paint facilities and try to figure out, they may not be the biggest sources. The biggest sources are the vehicles on the road and making sure that the power is carbon neutral. But I do want to make sure that whatever sources we can control, we have solutions for.
Excellent. Gina, any thought on that?
I would just say I agree with those comments wholeheartedly. I do think we're going to see more and more commitments come out from automakers, a little bit of a domino effect, clearly responding to the president's infrastructure plan and his clear goal for a carbon neutral future. So I do think we'll see more. And, we're a global supply chain. So, when Europe puts these kinds of requirements, it's inevitably going to impact the U.S. industry as well.
Thank you both. And I wish I had a lot more time, but I don't. So I need to move into the award itself. I want to let everybody know that's part of this webinar that you can apply for the Altair Enlighten Award, both on Altair's website and on CAR's website. And this is the first year that we've had sustainability categories. The first one being sustainable product. And if you were signed in earlier when Richard was speaking, we showed that is a production vehicle or major system module recognizing emissions, lightweighting, and safety advances. And sustainable process is a manufacturing award recognizing material reuse, recycling, and water conservation advances, and probably many more. And we did this because we've had some great nominations in the past, but we really haven't been able to recognize those. So Gina and Debbie, thank you for being judges. What are you going to be looking for when you look at these applicants? I'll start with Gina this time.
Yeah.
Okay. Well, I think I'm going to be looking for some transformational sustainability impacts, and obviously bold ideas, those kinds of innovations that have obviously clearly reasonable business potential to be scaled for high volumes, which I talked about a little bit earlier, and that can create long-term low carbon solutions and benefits for a true sustainable future.
Excellent. Debbie, your final thoughts on that?
I would probably look for creative solutions, something that people think you can't do. That seems to be my theme of my life, something new, exciting. And I totally agree with Gina. It has to be tractable, it has to be doable, and it has to make an impact on the planet.
Thank you. This has just been a fabulous webinar. Thank you to the attendees. Any questions that came in that we didn't answer, we'll be sure we do that, and we'll share the materials with you. Have a great Earth Day, everyone, and I hope this has got you thinking. Thanks, Debbie and Gina. Have a great day, everyone. Bye.
Thanks, everyone.